Let me see that board for just a moment. Or actually, here, here's the recorder. So guys, what you guys are going to be doing next is you're going to be putting these, right, so that the little model matches the strip that's right across from it. Okay? So if you look at this rectangle of F, it's the same rectangle that's glued down here. If you look at this polygon of E going that direction, it's the same one in the little piece as it is on the model. Okay, the little stripe. And so what you guys need to do is you need to mount these to a board so that they're nice and evenly spaced across. Okay, and then create these directly across from it. You're going to basically be pasting them down with like a glue stick or something. Okay, so let me make sure that the camera's seeing that. It is. So I think I'm going to hold it up. Excuse me. I'm going to hold this thing up so that it sees it a little bit better, because this camera doesn't seem to do too well. So we're missing A right here. Okay, so you guys can see that. Okay. So then after that, the next thing that you have to do, I'm back around to this side, is you're going to have to do an analysis of the folds for each of these, right? A, B, C, D, E, and F. So you're going to have to start out by saying strip A contains 4 folds in 2 pairs. Okay? So one pair is folded to the outside, the other pair is folded to the inside. The paired folds are parallel to each other, right? So that means that they're both going the same direction. And they are perpendicular to the length of the strip. Now you go to the next pair, right? You go through the same set of criteria that I just gave you. But what you'll find is that these are still parallel to each other, but they're at a 30-degree angle to the length of the strip. Okay? So what you want to do is you want to make an observation of all of the characteristics of the strips, then come back and make a observation of how those characteristics affected the model that was made. For example, if you look at D, or you look at C, C and D look almost the same, don't they? What's different about C and D?
Their outward folds on D is tapered, so it creates the top layer kind of at an angle.
That's correct. So if you look at the levels, leave that there. If you look at the levels on C, you see that all 3 of the floors are parallel, right? That occurred because all of the folds were parallel. When you look at D, look at the roof. The roof is angled, right? And that's happening because the outfolds are not parallel to each other. Now look what happens in E. Now none of the folds are the same, and the whole thing is now this very erratic object. Nothing is parallel. Nothing is level. Okay? And then you finally get to F, and you see that it's creating this sort of spiral. But as long as the folds are parallel to each other in pairs, you can make a level floor. Okay? So you guys are going to be asked for a 1-page written statement about that. Okay? All right. So I'm going to go stop this video. I'm going to go ahead and assign your homework right now also.